Hey, it works. All right. So, what? Okay, never mind. I'm going to explain a little bit how waves are formed, or the different types of swells that are generated via wind. There's lots of different ways that waves are actually generated along the surface of the water. You can have, like icebergs breaking off and hitting the water and then creating a little tidal wave or a little tsunami, or you could have volcanic eruptions happening from underneath the surface of the water, landslides, you could have earthquakes, which is essentially like, tectonic plate shifting, and that creates energy movement in the water, but wind. So, what essentially happens on a basic principle is when you have the wind blowing across the surface of the water, what happens is that wind creates surface tension with all of the little water molecules. And so if you imagine all these little water molecules are like dots, okay, for just this, all right? And as the water or the wind comes across this, all these little dots start rolling. All the water molecules start rolling. And as these water molecules start rolling, they start, stacking together a little bit, like snowballs. And so you have a little snowball, and then as the wind carries farther distances, that little snowball or water molecule rolls in bigger and bigger and bigger and bigger circles. So, as it rolls across the water, it creates bigger circles or bigger energy movement. Now, with that, let me explain this a little bit. You have a few different parts to a wave. So, up here, you have the crest of the wave. Wow. And down here, you have the trough of the wave. Wow. Wow. Okay? So, between the two top parts, or the crests, is essentially what you would call the period of the wave. So when it says like, hey, there's a swell coming in and it's like 6 foot at fucking 15 seconds. 15 seconds is the spacing right here. And the longer the water in the wind blows across the water, and the bigger that snowball gets, then the bigger distance in between the crests happens. All right. So now let's go a little bit further. You have two different types. You have warm air, and with the warm air, what happens along the surface of the water is you have the sunshine, wee, and wee, and it's heating up the water, okay, or the area around the water. And now when it's heating this area up, essentially what's happening is all the molecules are bouncing off each other like crazy. It's like being in a mosh pit or at a dance festival kind of thing, right? It gets a little hot and sweaty inside of there, and eventually you start looking for more room to dance because, let's face it, it's fun dancing in small areas, but it's also fun flowing. So all of these molecules are bouncing and hitting the surface of the water, but then they start to rise because, well, it's warm and it's looking for more areas to dance. So this area is doing that, and what happens is it's hitting the water and it's raising, and what happens is that molecule raises is it creates a low pressure in between that molecule and the water, and so that's what lifts the crest of the wave up. And then what happens is gravity takes the crest of that wave and pushes it back down. So you have a rise and then a drop. And so the further that this wind or this little pressure system moves across the surface of the water, a couple things. One, the taller these little waves are going to get. But then also what's going to happen is you're going to get to the edge of this little cyclone. Spacing on the name right now. You get to this edge of this little storm, right? And so the area from here to here where the wind is running across the surface of the water is called the fetch. And that's is what will create all these little wind waves. Now, when these little wind waves get to the edge of the wind and pass the edge of the storm, what happens is it turns into groundswell. And there is a period beyond this or beyond the edge of this storm where the wave will continue to get a little bit bigger, or maybe a lot bit bigger. And then you have just the point at which the energy starts to diminish again. And so when you're looking to surf, you're looking essentially to find the in-between of the edge of this storm and where the energy starts to diminish, because that's when the swell will end up being the best. Now, with warm air fronts like this, what happens is you end up getting a lot nicer, cleaner waves and a pretty decent swell spacing in between. So the energy is different once it builds. So, but what happens with this warm air when it rises? Well, this warm air, when it rises, it's looking for all that space, right? So it's looking for the cold side of the world. And so that's usually winter, and you know. And so it looks for the winter side of the hemisphere, or whatever it is we live on. And so it comes all the way up over here. And then it has all this space. And just like when there's space in between the molecules, it has time to cool off because it's not dancing on each other. And so then when it cools off, what happens is then it drops back down to the surface. And if it drops over the ocean, which is generally where it drops most of the time, over here, it drops into the ocean. What happens is all this energy goes down in. All this energy goes down into the water. And so with these cold systems, what happens is the energy goes a lot deeper right away. But also, the energy is a lot messier, or the waves are a lot messier and closer together. So with these cold systems, what happens is you get a lot more crazy energy and crazy water and stuff like that. And then the farther they get away from the storm, the little more spaced out that they get. And so let's say, you know, this is the edge of the storm, all right? And it's going out in all these different directions and stuff like that. And so it starts off, you know, crazy, crazy depth. And as it gets out further away, what happens is the period in between the crests start to space out. So the farther away from a cold storm it is, the more space in between the crests of the wave. And so for this too, you know, it has a sweet spot. So you got the edge of the storm where the waves are crazy big and whatnot. And then once it gets past the wind of that edge of the storm, it has an area where the energy starts to dissipate. And then it starts to get smaller. But for a little while, it carries on. And it gets generally it tends to get a little bit more organized when it's farther away from the edge of the storm. You know, it's about all I have for you. You have warm air, and these things start off slower, and then they get bigger, and then you have the cold air, and these things start off like this, and then they get like this. Comprende? Comprende.